welcome back. So what we're working on today is lesson 6, strategic solving. So let's go ahead and jump right in. All right, predicting solutions without solving. So we're not going to solve a single one of these. Identify whether these equations have a solution that's positive, negative, or 0. So if we look at number 1, we have x divided by 6 equals 3x divided by 4. We have an x on both sides of the equal sign. So what's it going to be? 0. The next one, we have 7x equals 3.25. Do we think this is positive, negative, or 0? Well, it should be positive. If we divide to solve, that's not going to change the sign at all. What about on number 3? 7x equals 32.5. This is also going to be positive because both of them are positive, so it won't change the sign when we divide. All right, what about number 4? We have 3x plus 11 equals 11. This one's going to end up being 0 again because the 11s will cancel out, and so we'll just be left with 3x equals 0, which means x has to be 0. All right, number 5, we have 9 minus 4x equals 4. What do we think? Is this going to be positive, negative, or 0? Got it? We'd subtract the 9. 4 minus 9 is going to give us a negative, and then we'd have negative equals a negative, so it'll cancel out, so we'll get a positive. All right. On number 6, we have negative 8 plus 5x equals negative 20. Will this be positive, negative, or 0? So we'd add the 8, but that's not going to change the negative 20 to a positive. And then we're dividing by a positive, so it's going to end up being negative. All right, and this last one here, we've got negative 1/2 times negative 8 plus 5x equals negative 20. So if we think about this negative here on the 1/2, it's going to go to both of these things. So it'll make the 8 positive, but it'll change the 5 to a negative. So then when we divide, it's going to end up canceling out the negative here on the 20, so it'll be positive. So we can use clues like this to help us in understanding what kind of solution we're going to end up with. So that helps us make sure that we have the right solution. All right, which would you rather solve? So there's a whole lot of equations here. We definitely have some complex ones. We've got ones with fractions all over the place. We've got ones with a lot of distributing. We've got ones that are entirely fractions. So there's a lot of different things going on in here. But basically what we're going to do is we're going to look at which ones we think would be the easiest, which ones we think would be the hardest. So my guess is you're thinking the fraction ones would all be pretty hard to solve. Just a hunch. And the rest of them would be the easier ones, the ones where we're just using the distributive property. So this is entirely just up to you as to what you think is difficult and what you think is easy. But there are all sorts of equations here, so I'm going to do just a couple of them so you can see some of like fraction ones, what we do when we've got these fractions like this. So that way you have some experience with those, but it's all about just having a strategy for being able to solve. So your keyword for this lesson is strategies. So I am going to do G. So we have 4m minus 3 over 4 equals negative 9 plus 4m over 8. So first thing we need to do is get rid of the fraction. So I'm going to multiply both sides by 8. So that completely cancels out there. So we have negative 9 plus 4m. And here, the 8 will cancel out the 4, but we'll be left with 2 still. So we have 2 times 4m minus 3. So 2 times 4 gives us 8m. 2 times negative 3 is negative 6. Equals negative 9 minus 4m. We add the 4m. Those cancel. We have 12m minus 6 equals negative 9. We add the 6 over. It's a very long problem. We have 12m equals negative 9 plus 6 is going to give us a negative 3. Divide both sides by 12. So m equals negative 1/4. So obviously there was a lot going on in this problem, but when you have fractions like this, to get the number out of the denominator, you just multiply by that number. Now, because this one had two separate fractions, luckily 4 and 8 were both 4 can go into 8, so it would cancel out, and the 8s canceled. They were similar enough, it worked. We just had to deal with this 2 left over. So sometimes that may happen. You may have to find the GCF, or not GCF, the LCD, to take and decide what you're going to take and multiply by. But most times it'll work out. Like on here over on C, you just multiply by 4 to both sides and then it would cancel out. So it works out fairly nicely. Now you could also do the same thing in A, multiply everything by 6, and that'll take care of these fractions for you. So it's all about distributing, combining like terms. So like F has a lot of combining like terms because we're distributing the 3, distributing the 2, but then we've got constants and variables all on the same side. So I'm going to go ahead and do F with you guys as well. So we've got, I'm going to write it down here, 3 times C minus 1 plus 2 times 3 plus, or 2 times 3C plus 1 equals negative 3C plus 1. So 3 times C is going to give me a 3C. 3 times negative 1 will give me negative 3. Plus 2 times 3C is 6C. And 2 times 1 is plus 2. Equals, we distribute the negative, so negative 3C minus 1. So now we combine like terms on the same side. So 3 plus 6 is 9, so we have 9C. Negative 3 plus 2 will give us a negative 1. Equals 3C minus 1. We add the 1. We end up with 9C equals 3C. So being as it's two variables on either side, we know C has to equal 0. So this one, despite, looking confusing because there were so many distributings going on, it ended up canceling out and just giving us C equals 0. So like I said, lots of different problems here, lots of different strategies to have to work through to figure out how to solve and what's the best option for solving some of them. All right, if you guys have any questions, feel free to ask. Hope you guys have a great day. Bye.